Working on lithium ion batteries. Lithium ion batteries are inherently popular these days. You can find them in laptops, PDAs, cell phones, and iPods. They are so common because, pound for pound, they are some of the most energetic rechargeable batteries available. Lithium ion batteries also have been in the new lately. That's because these batteries have a ability to burst into flames occasionally. It is not very common, just 2 or 3 battery packs per million have a problem. But when it happens, it's a extreme. In some situations, the failure rate can rise, and when that happens, you end up with a worldwide battery recall that can cost manufacturers millions of the dollars. Lithium ion batteries are popular because they have a number of important advantages over competing technologies. They are generally much lighter than other types of the rechargeable batteries of the same size. The electrolytes of the lithium ion battery are made of lightweight lithium and carbon. Lithium is also a highly reactive element, meaning that a lot of energy that can be stored in its atomic bonds. This translates into a very high energy density for lithium ion batteries. Here, it is a way to get a perspective of the energy density. A typical ion battery can store 150 watt hour of electricity in 1 kilogram of battery. They hold their change. A lithium ion battery pack loses only about 5% of its charge per month compared to 20% loss per month of the nickel magnesium batteries and etc. They have no money effort, which means that you do not have to completely discharge them before charging, as with some other battery chemistries. Lithium ion batteries can handle hundreds of the charge or discharge cycles. That is not say that lithium ion batteries are flameless. They have few disadvantages as well. They start degrading as soon as they leave the factory. They will only last 2 or 3 years from the date of manufacture where you use them or not. They are extremely sensitive to high temperatures. If you completely discharge a lithium battery, it is run it. A lithium ion battery pack must have an onboard computer to manage the battery. This makes them even more expensive than they are already. They are a small change in that if lithium ion battery pack fails, it will burst into flame. Now here's what is the inside a lithium battery pack and cell. Lithium ion battery packs come in all shapes and sizes, but they all look about the same of the inside. The lithium ion cells can be either cylindrical batteries that look almost identical to A cells, or they can be prismatic, which means that they are square or rectangular. The computer, which comprises one or more temperature sensors to monitor the battery temperature, a voltage converter and a regulator circuit to maintain safe levels of the voltage and current, a shielded notebook connected to that lets power and information flow in and out of the battery pack, a voltage tap which monitors the entire energy capacity of individual cells in the battery pack, a battery charge state monitor, which is a small computer that handles the whole charging process to make sure the battery charges as quickly and fully as possible. If the battery pack gets too hot during charge on use, the computer will shut down the flow of power to try to cool things down. If you leave your laptop in any extremely hot car and try to use the laptop, this computer may prevent you from powering up until things to cool off. Now, the lithium cells with the most batteries you have an outer case made of the metal. The use of metal is particularly important here because of the battery pressures. This metal case has some kind of the pressure sensitive vent hole. Now coming to the lithium ion life and death. The lithium ion battery packs are expensive. So if you want to make yours to last longer, here some of the things you want to keep in mind. Lithium ion chemistry prefers particularly discharge to discharge. That meaning is partial discharge to the discharge. And lithium ion batteries is they only last 2 to 3 years even if they are settling on shield unused. And coming to the exploding batteries, now that we know how to keep lithium batteries working longer. Now coming to the working principle of the lithium ion battery. Lithium ion batteries belongs to the group of batteries that generate electrical energy by converting chemical energy through redox reactions on that particular active materials. That is, the negative anode and a positive electrode cathode in one or more electrically connected electrochemical cells. Lithium ion batteries can be further divided into primary non-rechargeable and secondary rechargeable batteries depending on whether or not they are rechargeable by applying an electric current. In conventional lithium ion batteries, lithium ions are shuttled between the positive electrodes and a graphite based negative electrode according to the rocking chair principle. The term discharging is used for the process in which the battery supplies electrical energy to an external load. The electrolyte in this system contains additional lithium ions to ensure rapid transport of the ionic charge within the cell. Besides ion conduction, the electrolyte fulfills the other important purposes is support of the formation of the effective interfaces. Example, solid electrolyte interface, cathode electrolyte interface, in which enable the battery to function, or well lithium ion conducting, or protective against further electrolyte decomposition. Contribute to the cell safety being inserted to the other materials such as separator, current collectors, conductive additives, binders, cell casing. Coming to the step 1, the step 1 is initial state of charge of SOC 0%. When charged, the lithium ions are in the positive electrode material. Thus, the positive electrodes is the source of the lithium ions necessary for the conversion of the electrical energy into chemical energy to allow lithium ions migrate from the positive electrode to the negative electrode. The electrolyte is also enriched with lithium ions. Step 2, formation of SCE and CEI. In the very beginning of the first charging process, electrons migrate from the positive electrode material oxidation through an external conductor into the negative electrode material reduction. To ensure charge neutrality, the lithium ions detercalate from the positive electrolyte material into the electrolyte and migrate through the electrolyte to the negative electrode material for subsequent storage. As a result of these reactions, boundary phases, so called SCI and CEI, are formed at the interfaces between the electrolyte, negative electrolyte surface, and electrolyte or positive electrolyte surface respectively. These interfaces are built up from insoluble electrochemically induced decomposition products of electrolyte components and lithium ions organizing from the positive electrode and enable a reversible cycling of the battery. After formation of the SCI and CEI, further lithium ions de-intercalculate from the positive electrode material into the electrolyte and migrate through it to the negative electrode material to the subsequently incorporated into the latter. Now coming to the step 3, electrode reactions. All after the formation of the SCI and CEI, further lithium ions de-intercalculate from the positive electrode material into the electrolyte and migrate through it to the negative electrode material to be subsequently incorporated into the latter. Coming to the step 4, color change during intercalculation or de-intercalation into the graphite. Depending on the number of lithium ions embedded in the negative electrode, depending on the state of charge SOC, it changes the color from black over red to the gold. And step 5, discharge. During discharge, the reverse reactions are taking place. Step 6, rocking chair principle. After discharge, the lithium ions are restored in the positive electrode material from which they are originally came. The back and forth movement of the lithium ions remains of the movement of the rocking chair, which is why this principle was called rocking chair principle. Especially the first cycle, charge and discharge, is associated with an irreversible loss of lithium ions and also in the negative electrode material. As a result, few lithium ions are now able to be stored in the negative electrode in the following charge cycle, which leads to a reduced capacity of the battery. Different aging process take place in the lithium ion battery, which reduces the performance of the battery over the period of use and depends strongly on the cell chemistry and the intended to use of the battery. Especially, the right choice of the electrolyte has an enormous influence of these aging mechanisms and underlines one more the importance of the tailor-made electrolytes. In order to optimize lithium ion batteries with respect to the specific energy and energy density, lifetime and safety, many efforts have been made to further extend the application possibilities of this, especially the increasing demands for the both high specific energy and energy density. Lithium ion batteries, particularly for automotive applications, raise the research efforts all over the world. The energy density and specific energy of batteries by defining is the amount of energy stored in the given system per unit volume and per unit mass respectively. Now coming to the summary of working principle of lithium ion battery. Lithium ion batteries work on the rocking chair principle. Here the conversion of the chemical energy into electrical energy takes place with the help of the redox reactions. Typically, a lithium ion battery consists of two or more electrically connected electrochemical cells. When the battery is charged, the ions tend to move towards the negative electrode or the anode. When the battery gets completely discharged, the lithium ions return back to the positive electrode, that is the cathode. This means that during the charging and discharging process, the lithium ion move back and forth between the two electrodes of the battery, which is why the working principle of lithium ion battery is called rocking chair principle. Coming to the lithium ion battery, a typical battery consists of the two electrodes, namely anode and cathode. Cathode forms the positive terminal of the battery, and anode is the dedicated as the negative terminal. The cathode of the lithium ion battery is mainly composed of the lithium compound, while the prime element of anode is graphite. When the battery is plugged in with an electricity supply, the lithium ion tends to move from anode to the anode to the cathode. That is, cathode to the anode, from the positive electrode to the negative electrode. This is known as charging the battery. During discharging phase of the battery, the movement of the lithium ions gets reversed from the anode to the cathode, that is, from negative electrode to the positive electrode, and electrically energy gets transmitted to the attached load. What are the uses of lithium ion battery? Cellular devices. Almost all cellular devices such as the mobile phones, laptops, cordless phones, etc. make use of lithium ion batteries. This is because lithium ion batteries are compact, lightweight and reusable, hence they are preferable to fit for handheld devices. Also, such types of the batteries provide a quick charging rate, thereby allowing the user to access the devices frequently without disturbance. Another one is the power banks. A power bank is a portable gadget that helps to use conveniently charge the electronic devices such as the mobile phone, smartwatches, etc. anywhere and anytime. For this purpose, a power bank typically makes use of lithium ion and lithium polymer batteries. Coming to the electrical vehicles, a number of electrical vehicles such as the electric cars, electric bikes, electric scooters, electric cycles, etc. employ lithium ion batteries for their operation. This is because of lithium ion batteries have a high power to weight ratio, greater tolerance to temperature and pressure vibration, and a higher energy density lead acid batteries. Also, they are light in weight, portable, efficient and safer than the traditional batteries. Coming to the medical devices, the medical devices such as hearing aids, surgical tools, diagnostic machines, pacemakers, defibrillators and medical assistant robots and infusion pumps, heart and pulse rate monitors, etc. employ lithium ion batteries for various diagnostic and treatment purposes. The advantage of using lithium ion batteries in medical gadgets include the high responsiveness, quick charging rate, lightweight and non-hazardous nature, etc. Coming to the cameras, lithium ion batteries are highly used in digital SLR cameras because they are able to provide high power for comparatively longer duration than traditional batteries. Also, lithium ion batteries are preferred because they are light in weight, hence do not make the gadget bulky. Some of the cameras also makes use of the rechargeable lithium ion batteries that enable the user to reuse them and improve reliability. UPS, a uninterrupted power supply system, is a device that provides a power backup for a certain time period in case of the power cut or failure. Such devices typically make use of a combination of lithium ion batteries. This is because of the use of the lithium ion batteries in UPS devices reduces the floor space by 50 to 80%. And also, lithium ion battery based used UPS system weighs 60 to 80% less than the generic lead acid based UPS device. Robots. Lithium ion batteries are highly preferred in the robotics and automation fields of the science. They are used to power handheld robots as well as the industry's robots. Coming to the advantages of the lithium ion battery, first one, lithium ion batteries have a significantly low self-discharge rate as compared to the other type of the batteries. Second one, they have a high energy density. Third one, there exists no memory efforts in the lithium ion batteries. Fourth advantage is the average lifespan of the lithium ion batteries in 10 times more than the traditional lead acid batteries. Fifth one, the charging rate of the lithium ion batteries is high. Next one is lithium ion batteries work efficiently under extreme conditions such as the high pressure and temperature fluctuations. Seventh one is the lithium ion batteries are high weight and compact in size. Typically, the weight of the lithium ion batteries is roughly 50 to 60% less than the standard lead acid batteries. Installation of the lithium ion batteries is comparatively easy. These types of the batteries are flexible, less bulky, and safe to use. Lithium ion batteries are available in a variety of the shapes and sizes. The voltage level of a lithium ion battery does not drop and is maintained constantly throughout the use. This is the one of the advantages here. And they require low maintenance. Lithium ion batteries are non-hazards as they do not emit any toxic gas. And coming to the disadvantages of the lithium ion battery, the charging capacity of a lithium ion battery gets reduced over time because of the loss of the lithium ions in the solid electrolyte interface and cathode electrolyte interface. If the separator of the lithium ion batteries gets damaged, they are susceptible to fire hazards. They are relatively expensive. If the battery runs out of the lithium ions, it cannot. Lithium ion battery cell, module, and pack. The technology and cost challenges in the lithium ion batteries. The current battery performance of lithium ion batteries is not sufficient to be widely used in hybrid electrical vehicles, PHEVs, and electrical vehicles. In addition to necessary increase in energy and power density performance, other improvements are needed in durability, safety, and cost. Coming to the durability, batteries in electrical vehicles requires to have a reliable durability for deep cycles to keep longer lifespan. Vehicle makers are aiming to develop lithium ion batteries with a guaranteed 5 years or 10,000 kilometers drive distance. Deep cycle lithium ion batteries decrease the battery capacity rapidly, but electrical vehicles will be charged after the battery stored energy is almost depleted. In addition, the power of lithium ion batteries decreases in cold weather. For use of electric vehicles in cold regions, further technology is developed will be necessary to overcome this problem. And another component is the safety. Lithium ion batteries are valuable to short circuiting and overcharging here. Lead acid, nickel, cadmium, and nickel magnesium batteries perform safely even after short circuiting and overcharging because batteries are short circuited. High electricity flows are created and battery temperature increases the several hundreds degrees within the seconds. Heating is neighboring cells and resulting in an entire battery combination reactions. When lithium ion batteries are unintendedly overcharged, the chemical structure of the anode and cathode are destroyed and some of the battery to short circuit or in worst case scenario explore the catch fire. Impurities in the lithium metal can also be contaminated in the batteries and cause the formation of the dendrites differentially, potentially represented in the casing short circuits and explosions. To prevent overheat charging, lithium ion batteries must be sold as a battery packs with a very precise voltage control system. In other words, cells cannot simply be installed into a given electronic applications. And third one point is the cost. The high cost of lithium ion batteries for electrical vehicle is a critical concern. According to the most recent estimates available for the batteries, For electrical use, the cost of lithium ion is 4 to 8 times that of the lead acid and 1 to 4 times of the nickel magnesium oxide. However, the cost of the lithium batteries is expected to decrease significantly because of the batteries will be increasingly used for many applications such as UPS, forklifts, consumer electronics, and backup power supplies. As the market grows and production scales up, manufacturers will be able to enjoy economic of the scale. Now coming to the nanotechnology related electrical vehicles. Several potential materials development to increase the performance of the further batteries will be accomplished with the use of the nanotechnology, creating nano-sized materials through atomic scale manipulations. Nanomaterials demonstrate different chemical and physical properties from the micro-sized materials 10 power minus 6 meters because of their significantly smaller particle size. The unique properties of the nanomaterials offer significant potential to improve battery performance. Nanotechnology is expected to improve the performance of the three parts of the lithium ion battery: cathode, anode, and separators. And this figure shows a roadmap for battery technology for electrical vehicle, including the development of lithium ion batteries from 2010 to 2030 and next generation batteries emerging after 2030. These new types of battery materials will increase the performance of the future batteries through higher density, power, and safety. Coming to the some examples of the nanotechnology applications for lithium ion batteries. One is the here is example materials. One is the anode. Carbon nanotube CNT, one of the most anticipated next generation anode materials, improves the power performance of the lithium ion batteries by a factor of 10. The CNT will be used as both anode and cathode electronic conductor and also anode active material. Coming to the anode, the scenario of nano-sized new type anode, lithium titanate oxide, can be charged very quickly so that 35 kilowatt hour battery pack can be charged in 10 minutes. Next one is the separator. A new type of nano-sized ceramic separator enhances the battery safety because of its robustness and stability in high temperatures. Some nanomaterials can be constructed through bottom-up approach, which entails tailoring of the nanomaterials at the atomic level instead of the less precise materials. This opens up potential for many innovative approaches to lithium ion battery development. For example, a team of the Georgia Institute of Technology developed a new silicon and carbon nano composite anode material such demonstrated 5 times the energetic capacity compared to the conventional graphite anode. Many of other lithium battery performance improvements are continuously being reported in that particular scenarios. Thank you. Thank you.